Okay, let's unpack this. You've probably heard the buzz about AI, right?
Yeah.
And maybe even interacted with agents, ones that can write code.
Uh-huh.
But what does it truly mean when these intelligent systems start acting like actual developers,
Yeah.
executing commands all on their own?
Yeah.
Today, we're diving deep into the fascinating and I'd say absolutely critical world of securing these code-executing AI agents.
A big one.
We're drawing insights directly from OpenAI's own experience, especially with systems like Codex, to help you understand what's really going on behind the scenes and, frankly, why it matters so much.
Absolutely. And the mission for us today really is to distill the core challenges and also the pretty ingenious solutions emerging around AI agent security.
Right.
We'll be focusing heavily on insights from Fuad Matam. He worked on OpenAI's security team, now focuses on agent robustness control. So he offers a really unique perspective right from the frontier.
Okay, so AI and code, I think for a lot of us, the first thought might be, AI helping a software engineer, like a fancy autocomplete.
Yeah, like a co-pilot kind of thing.
Exactly. But here's where it gets really interesting. Our source reveals the reality is actually far broader and maybe a little more surprising.
Well, what's fascinating here, and this is a key point from the source, is that every frontier research lab is pushing hard on coding capabilities.
Not just benchmarks, you mean?
No, not just benchmarks. It's about usability, deployability. The expectation really is that almost every AI agent will become a code executing agent eventually.
Wow, okay, every agent.
Yeah, it's not just about writing lines of code anymore. It's about achieving objectives more efficiently. Think about, say, multimodal reasoning.
Mhm.
Before, an AI might just look at an image, right? Now, with code execution available, even if you don't tell it to, it might just decide to use OCR to read text in the image.
On its own initiative.
Exactly. Or crop it or analyze something specific. The model's just figured out, hey, with code as an option, I can be way more efficient.
And that leads to a fundamental shift in how these agents are actually built, doesn't it? It sounds like those complex sort of inner loops we used to hear about, where the models determine tasks, loaded prompts, chained actions. That's changing.
Yeah, that's evolving. Now, the model itself can decide, okay, when do I use this tool? When do I use that one? And crucially, when do I write or run some code?
So the inner loop is becoming autonomous.
Precisely. And this newfound autonomy, I mean, it's incredibly powerful, obviously, but it raises a really important question from a security angle.
Which is?
Well, in the security world, allowing a system to just write and run code on its own, we call that remote code exploitation. RCE.
Right, RCE. That sounds bad.
It is bad. Usually it means an attacker running code on your machine, but when it's your own AI doing it, the implications are significant. It's not some external hacker. It's potentially your own tool acting in unexpected, maybe harmful ways.
Okay, so we've got these agents potentially running wild with code capabilities.
Yeah.
What keeps me up at night, then, is how exactly can they screw up? What are the biggest blunders or maybe even malicious things they could do? What are the potential backfires for you, the listener, if you deploy one of these?
Right. Well, the most common risk, and definitely the highest priority one, is prompt injection leading to data exfiltration.
Okay, explain that a bit. Prompt injection.
So imagine some untrusted external content, right? Maybe a comment someone left on a GitHub issue the AI is reading, or some text in documentation.
Okay.
If that comment contains cleverly hidden instructions, it can subtly inject those malicious instructions into the agent's thought process, its workflow.
Yeah?
And then, if the agent has access to sensitive stuff, like your code or data, it might be tricked into leaking it. That's the data exfiltration part, sending your secrets off somewhere.
Yikes. Okay, so that's number one. What else?
Beyond that, I mean, agents can just make mistakes, right? Honest errors. Maybe it unintentionally installs a malicious software package because it looked legitimate.
Right, like a typo squatted package name or something.
Exactly. Or it writes code that has vulnerabilities baked in, opening doors for actual attackers later. Or things like privilege escalation.
Where it gets more access than it should.
Yeah, it starts out limited, maybe just in its own directory, but finds a way to get root access or admin rights. Or even sandbox escape, breaking out of that isolated environment it's supposed to stay inside.
Okay. These are definitely critical things to think about if you're deploying or even just building these agents.
Absolutely critical.
So given these, pretty significant risks, how does a company like OpenAI actually tackle securing these systems? Our source mentioned a preparedness framework, 3 pillars.
That's right. They have a structured approach. The first pillar, and you could argue it's the most robust method, is to sandbox the agent.
Sandbox, like a digital playpen.
Exactly. Think of it as giving the AI its own completely isolated computer, or maybe a container, a digital fortress.
Right.
This is precisely what OpenAI does with Codex and ChatGPT. The agent does its work entirely inside this isolated box.
Ah.
And any output, like if it suggests a code change, that comes out as a pull request for a human to review. The source describes this as practically as safe as you can get, because the AI's actions are contained.
Okay, practically as safe as you can get sounds great for OpenAI. But, for maybe a listener building their own agent, perhaps using something like the Codex CLI on their own machine, how do you replicate that? Isn't sandbox escape like a classic security problem?
That's a really sharp point. And yes, you absolutely still need to provide the right level of sandboxing, even locally.
So how?
Well, it could be containerization, like using Docker, or maybe applying isolation at the ACK level, or even the OS level. For instance, the source mentions that on macOS, OpenAI uses a language called Seatbelt.
Seatbelt. Never heard of it.
Yeah, it's actually bundled by Apple into macOS, kind of inspired by how the Chromium browser handles security. On Linux, they use Rust, along with tools like seccomp and landlock.
Okay, those sound technical.
They are. They're powerful Linux kernel features that let you define very precisely what a program is allowed to do and what it's not allowed to do. So you create this really tight perimeter.
Got it.
What makes it tricky with AI, though, is the code it generates is dynamic, unpredictable sometimes. So the sandbox needs to be flexible enough for useful stuff, but rigid enough to stop the bad stuff. It's a balancing act.
Right. Okay, so pillar 1, sandboxing. What's pillar 2? It
Yeah.
sounded almost counterintuitive, disabling internet access.
Yeah, limiting or disabling internet access. It does seem counterintuitive for an AI, right? They need information.
Exactly.
But the source calls this the highest probability vector for prompt injection and data exfiltration.
Why specifically the internet?
Well, think about it. Every time the agent reaches out to the internet to read documentation, check a GitHub issue, whatever, it's potentially touching untrusted content.
Ah, okay. The external content again?
Exactly. That malicious prompt we talked about could be hiding anywhere online. If it gets pulled into the agent's inner loop, and the agent has internet access plus access to your sensitive data,
Then it can just send it out.
precisely. It could be tricked into posting your private API keys or code snippets to some random URL, like HTTP bin, which is often used for testing, but here could be a leak vector.
Okay, so how do you control that without completely crippling the AI?
OpenAI offers a couple of approaches. One is a full auto mode. In this mode, the agent can basically only read and write files within its own directory, and it can only make network calls based on commands that are pre-approved, like running tests or PyTest and PM test. This avoids those second-order consequences like accidental data leaks during testing.
So limited but safe for certain tasks. What's the other option?
The other is more flexible,
Yeah.
a configurable allowlist for internet access. You basically define exactly which domains, which HTTP methods are permitted.
So you could say, okay, you can get DT from api.example.com, but nothing else.
Exactly. And it comes with warnings about the risks involved. The key, really, is combining controls at the model level where the AI itself might flag suspicious activity with deterministic controls at the system level, which just block forbidden actions outright.
Model smarts plus hard system rules.
You got it.
Okay, so sandboxing, internet controls. Pillar 3, requiring human review. This feels essential, but also maybe difficult. If the AI is generating tons of code, how practical is manual review?
That's the million-dollar question, isn't it? And you're right, while AI tools can help with code review, maybe spot obvious issues in a pull request.
They're not a silver bullet.
Definitely not. They are not, and probably won't be anytime soon, a complete substitute for experienced human eyes. A model might install some obscure package it found somewhere.
That nobody's ever vetted.
Right, or it introduces a tiny, off by one error, just one character wrong, looks innocent, but in the wrong place, in a privileged environment. It could be disastrous.
Yeah, those subtle bugs are the worst.
There's a level of maybe intuition or broad context that humans have. So humans need to stay in the loop, stay in control, make the final call.
How does OpenAI handle that balance? You don't want to review every tiny thing, right?
Exactly. They use things like domain allow lists, but also a watch mode for their internal operator agent. Certain potentially sensitive actions automatically trigger a human review.
Ah, okay. So it flags the risky stuff.
Yeah, it's about finding that sweet spot between maximum security and maximum flexibility. You absolutely don't want YOLO mode, where anything goes.
Me, definitely not YOLO mode.
But you also don't want the user having to manually approve every single tiny command like del's to list files.
Yeah.
That would just be unusable.
Right, finding that practical middle ground. Okay, so for people listening who are thinking about building their own agents, how can they actually apply these principles? Are there tools emerging to help?
Yeah, definitely. The trend seems to be shifting towards deferring most of the complex logic to the reasoning model itself. Your job as the builder is more about giving it the right safe tools to use.
Okay, like what kind of tools?
Well, OpenAI has released things like local shell directly in their API. This is exactly the kind of tool they use internally to train models to write and run code safely.
So you can give your agent a controlled shell environment.
Exactly. They also provide a tool called Apply Patch. Models apparently aren't great with line numbers in standard git diff outputs, so this helps them apply code changes correctly.
Ah, interesting detail.
And then standard things like MCP web search are available too. But a really great practical example the source gives is exposing a dependency vulnerability checking service to the agent, like Socket's MCP server, for instance. Before the agent installs a dependency, it can query this service. Hey, is this package some obscure library known to be vulnerable or suspicious?
Oh, that's smart, catching it before it even gets installed.
Exactly, preemptive security. And again, the strong recommendation is to use a remote container for the actual execution. OpenAI is even planning to release a container service as part of their agent's SDK and responses API, making it easier for everyone.
That would be helpful. Okay, so let's try to quickly recap this deep dive. Securing these code-executing AI agents. It really seems to boil down to three core strategies, right? One, robust sandboxing, keeping the agent contained. Two, smart strategic control over internet access to stop those injections and leaks.
Yep.
And three, essential human review as that final critical safeguard. It's like building a really strong fence around something incredibly powerful, but also potentially unpredictable.
That's a great way to put it. And while there's been huge progress, especially with those deterministic controls like sandboxing and allow lists, the genie isn't over.
Still work to do.
Oh, yeah. We expect a lot more research, particularly around how to effectively use other language models, LM-based monitors, to help with that human review step. They're not quite there yet for, full certainty, but they're improving.
So AI watching AI, eventually.
Potentially, yeah. And more tooling, better documentation, it's all coming. It signals this is a really active and evolving field.
What's kind of compelling to think about here is it feels like the future of AI safety really hinges on this constant evolving dance.
Yeah.
Between these increasingly autonomous AI capabilities on one side and smart, adaptable human oversight on the other. It's a balance, and finding that right balance seems like it's still very much a cutting-edge area of R&D.
Absolutely. It's where the action is right now.
So for you listening, maybe think about where these agents might fit into your world, your work, and if you're building or deploying them.
Yeah.
What safeguards would you prioritize? Because getting this right, securing these systems, that feels paramount for them to be adopted safely and widely.